So we're here at Table Mountain Observatory. It's the Pomona 1-meter telescope. It lives on a Jet Propulsion Lab, JPL, research facility, which is about an hour north of Pomona College campus. It's about 7,000 feet, so a dark site away from the LA city lights. We just started our summer research program. We normally have students for 10 weeks over the summer. This summer I have 3 new students, and they'll be working on a couple of different projects. And so we brought the students up here, have them see the facility, have them work on some of the hardware.
This is actually my first time here, so it's definitely very exciting to be here. I feel like it's a lot taller than you think.
We just put a new camera in called Zymia, and we need to fix where the focus is, so we're taking out a few lenses. We are observing at night. We have a few test targets, which are basically exoplanets, and then we might be observing some NEOs, which are like asteroids.
It's just such a powerful thing to have a facility like this. It really takes learning to the next level, in my opinion.
The Table Mountain facility is one that was built by Pomona faculty about 3 decades ago. And since then has been kind of a test bed for instrumentation development and various astrophysical observational projects. The thing that makes it special is the hardware on the back end is doing something that very few other facilities do. So what that means is that we can track objects with much higher precision than most of our collaborators. We have multiple projects going on. The first one we're going to be working on is we're looking at near-Earth asteroids. These are potential impactors. We have been working for years trying to discover these things, determine their orbits, and decide whether or not they're potentially hazardous. If they are, we follow them up. People are trying to understand our technique, but I think our results speak for themselves. This error bar, that error bar, and that.
Right now we're in the remote observatory, which is a room on the Pomona campus in the physics building. With our remote observing facility, we can kind of combine the advantageous location of having this telescope be on a mountain with the ability to control it and have students interact with it daily from Pomona campus. I did not think coming in that I would have the level of hands-on experience, the level of interaction with senior researchers at NASA's Jet Propulsion Laboratory, the level of interaction with collaborators around the world. And they also recognize the role that students play in outlining the science projects, in getting the telescope and the facility to where it is today, and in performing all of the science operations from raw data to reduction to analysis to conclusions and then iterating. And so because the students are the ones who are the experts on all of these things, we're taken very seriously by the researchers that we work with.
One of the things that a lot of my collaborators outside had really encouraged us to do was just roboticize the thing from day one, have it be a workhorse, and just pump out science. And that would have really cut out students at an early stage, and so I've resisted that for a decade. We really allowed the students to kind of be involved in the development of hardware, development of software, and then the running of science projects. I've had students literally build $1 million hardware projects in our basement. And so every generation of student that comes in has kind of made some contribution to this facility, which is amazing because then my collaborators from all over the world are using this telescope, and they're always asking, like, do you have engineers? Who's doing this? And it comes from students.
Go up to the DNC set.
Right now, we could look at some near-Earth asteroids, or we could look at things like galaxies, so like the pinwheel galaxy, or globular clusters of stars.
I think something that I really appreciate since being here with learning is that you're kind of never babied and your abilities are never underestimated. You are always perceived to have the capability to do things hands-on.
I think people are surprised to hear that we actually have collaborations with top-tier researchers who are very serious about engaging with us and using kind of our expertise and our facilities here.
The skill set of developing science and engaging in it is very unique for an undergraduate institution. This experience for me didn't come until I was a graduate student, to be frank.
Students are not underestimated whatsoever. It's pretty awesome.